surds with this. So the square root of 4 is actually 2, so that's not really a surd, but a surd would be like the square root of 5, which is not, you can only express that as a whole, like as that number as a surd, because it is irrational. It doesn't end its decimal places. It's approximately equal to 2.2 because it sits between square root of 4 and square root of 9. So you can think of your squared numbers, and the square root of those would be there. So the square root of 18 is approximately 4.2 because it sits between the square root of 16 and 25, and it's closer to 16. We looked at breaking up this and simplifying this surd, and that's what we call simplifying surds. So we look at simplifying. So if it says simplify, you know, what we want to do is you want to look for squared numbers that multiply to give you this. So it's, for example, 9 times 2. Then you can take that out because it's actually the square root of 9 times the square root of 2. The square root of 9 is actually 3. 3 times root 2 is 3 root 2, and that is equal to that. So that's how you simplify a surd, and you can take that out. You can't go 9 plus 9, because if you do 9 plus 9, well, you can do that. You can't actually go square root of 9 plus square root of 9, because that's actually 3 plus 3, which equals 6. And then we know this equals 4.2. Think about this, square root of 2 would be like probably about 1.1, 1. You know, something like that. And 3 times 1.1 would, or maybe 1.4. And 3 times 1.4 would give you about 4.2. So that makes sense why you can do that. So you can only simplify them using multiplication and division. So let's get into a couple of examples for you guys. I'm just going to quickly go through another one as well. So if I say, hey, what's the square root of 16, for example? This is another example. Now you know that equals 4, but I'm just going to separate this a little bit. I'm going to say it's the square root of 4 times 4. I'm going to show you a proof why it's 4. If you think about what the square root of 4 by 4 is, well, I could actually then say it's, well, the square root of 4 times the square root of 4, which equals 2 times 2, and 2 times 2 actually equals 4, which means it's the same thing. So that's how we can get to that. Similarly, if I do, well, the square root of 64, we know that that is going to be 8, but let's just do it with the square root of, well, I could do it as 4 times 4 would give me 16, times 4 would give me 64, right? So I can actually say that's the square root of 4 times the square root of 4 times the square root of 4, right, which is 2 times 2 times 2, which is equal to 8. So I'm just trying to show you how these rules do actually work. So if you get something like the square root of 50, for example, and I need to simplify that, I'm going to think of, well, what number goes into this as a square number? I know. I can do the square root of 25 times 2, which really, this is my thinking, okay? I don't really write it when I'm in senior years, but for the moment, if you're still learning this, you will write these steps down. So the square root of 25 is 5. So that's going to be 5 root 2. You can't do that. So that would be simplified as an answer for that one there. All right, so let's look at some of these examples. So you might actually have a question that says, for example, simplify the square root of 2, oops, sorry, the square root of 2 times the square root of, let's go with, there's a number there I was thinking of, 6, that's what I wanted. Now, remember before, well, we could, you know, when they're times each other, you could actually go upwards. So if you think about this, you can go down through any of these steps, but you can also go up through any steps. So if I've got these two together and they're both the same square, like they're both square root, like one's a square root and one's a cube root, you can't do it. That means I can actually times these numbers together and then bring them together. So I can actually say that that is really the square root of 2 times 6, which is actually the square root of 12, right? Okay, cool. Now, that might be your final answer, but have we fully simplified it? No, I should still check for square numbers. Actually, I can rewrite this as 4 times 3, because the square root of 4 is actually 2. So that is 2 root 3. So sometimes when you're simplifying, you might have an answer like this, and you just multiply them together. When you get to this answer, think of, is there any squared numbers that I can do to multiply that? Actually, 4 times 3, and then you can simplify that even further. So that's where they get a little bit tricky, where you can see some things like that. So this is probably the hardest section of surds. I'll give you some easier examples. That's sort of more of a harder one. You'll see this one in the textbook. Square root of 3 times square root of 10. If you have any think about this, okay, we can multiply these two together because they are multiplied. It's really 3 times 10, which is going to be the square root of 30, okay? Now I'm thinking of what are all my factors of 30? I know there's no square numbers, so I'm kind of going through my head like 1 and 30, which is just silly. I know I've got like 5 and 6, but none of these are squared numbers, so I can't square root them. I've also got 10 and 3. Well, I already had 10 and 3, so I don't need to do that. And I can't really think of, oh, there's 15 and 2. So none of these numbers are squared numbers. So really what I'm doing when I get to this stage, okay, when I get to, sorry, this stage here, I'm kind of thinking, I'm looking for squared numbers. To simplify further. So for example, when I had this scenario, I got to 12, I thought, oh, 1, 12, 3, 4, bingo, 3 and 4 I can do, right? And then I also thought of another thing. Now, if you're really stuck with it and you can't do it, you can also do a factor tree. So we could have done a factor tree here with 12, and I could have gone with 2, 6, and then 2 and 3. And because I've got two 2's, I know that 4 would give me root 2 because it's 2 times each other. So I could have actually also written it as, instead of this stage, I could have written this as the square root of 2 times 2 times 3. And because I've got 2 of them here, I know I can just take that out, which is going to be 2 root 3. And that's another way of doing it. So if I wanted to look at 30, I could do a 30 factor tree, 6, 5, 3, and 2. Notice I've got no double ups, so therefore I know it's just as simplified as that. So if I ask you guys like to do a really difficult question, like this, you're going to be like, oh, how do I do that? Well, I'm going to go 1, 2, 5, 6. If you halve that, that's going to be 628 times 2, I think it is. Yep. That looks pretty good. 600 will give me that. 28 will give me this, yes. And then it'd be 314 times 2. And then it would be 157, which I don't think has any more further factors. This would be like 157 times by 2. So I can see that if I have to do the square root of that, I've got two 2's here. So it's actually going to be 2 root 314 because that's there. 3 would probably go. No, I don't think that would be about it, sort of as you go. Now there may be more. I'm not too sure, but I'm just going to leave it there. All right, so let's go on to some other things. So really, the general rule for this is if you have a surd multiplied by another surd, it will actually, you just multiply those two together. Okay, that's what it will be. Similarly, the same thing happens with division. If I've got something divided by another surd, that will equal that on that. So let's look at an example for that one. So if I've got, for example, square root of 20, it should be 20, divided by the square root of 5, that is going to equal the square root of 20 on 5, which is the square root of 4, which actually equals 2. So same thing with division. So multiplication, division, you can bring them in. We can also then do that also with the distributive law then. So if I've got 5, for example, if I've got root 5 times root 2 plus root 3, I'll look at multiplication here. Well, we actually multiply these when you actually do that. So if you're ever multiplying surds, you just multiply the numbers in between. So it's going to be root 10 plus root 15. Now I can't add these together because they're not similar. I'm also looking for numbers that can come out of these, and there aren't any. Okay, sometimes you might be able to simplify these down and it comes to the same number, and then you can add them. So that's pretty much the hard rules of multiplication division. Now I'm just going to look at some addition and subtraction, and that's really easy. So I'm just going to do a question for you straight out of the book. So if I've got root 7, 3 root 7 plus 5 root 7, this is basically, because these are the same surds, you've got 3 times root 7 and you've got 5 lots of root 7, basically. 3 lots of root 7 and 5 lots of root 7. That's going to give you 8 lots of root 7. And it's exactly the same thing as algebra. because you've got the same lot of this quantity, as long as this quantity is the same, which it is, you can add them together. Okay, same thing then with subtracting. If they are the same surd, they're the same value, then you can subtract them. That's going to equal -2 root 7. Now, if I go, for example, 5 root 8 plus 3 root 2, you'll be like, oh, I can't add these because they're the same. Simplify your surds first. This is actually 5 . So you always want to try and take out square numbers where you can and simplify them, okay? Because that's actually now going to be 4. Now, if you think about that, that's actually going to be 5 times root 4 times root 2 plus 3 root 2. This will turn into 2. So it's actually going to be 5 times 2 times root 2. So when you bring this number out, you multiply it. I'm actually going to multiply that by 2 because that would be like root 4 is 2. So it's actually 5 times 2. So that's going to turn into 10 root 2 plus 3 root 2, which equals, now they're the same, 13 root 2. And that's all the laws, guys. That's pretty much it. And then it really just pulls into things with fractions. So I think you'll be fine with fractions. So I'll just do a quick one with fractions, but I think you'll be okay. I know you're pretty good with fractions from my previous knowledge. So a thing with fractions might be, for example, 5 minus 2 root 3 on 3 plus root 3. If I had to simplify this, okay, well, it's actually, I've got to make this the equivalent fraction as that one. So if I make everything in 3, that would be like 15 on 3. So what I'm doing here is I'm timesing this, making everything with the denominator on 3, minus 2 root 3 on 3 plus 3 root 3 on 3. So what I've done here in my head is I've just gone, I want this to be denominator 3. So I've got to times, this is 5 on 1. So I've got to times everything by 3. This is root 3 on 1. So I need to times that by 3. And that would then turn that into 15 on root 3, and that would turn that to 3 root 3 on 3. So that's how I got each of these parts into root 3. Now, because they're all the same denominator, I can just add and subtract the top. So that is going to be 15. And if I've got -2 root 3 plus 3 root 3, that's going to leave me with just one of the root 3s. It's going to be positive plus root 3 all on 3. Or you could write it as, because that's going to turn into 5 plus root 3 on 3. Yeah, and that is it. So love a bit of your feedback about how well you feel about that. But pretty much dividing, don't forget, and same thing with multiplication. So multiplication, dividing, you want to make sure you get into the same kind of denominator, simplified surd first. So there's sometimes things that you're going to see, hey, that doesn't really work. So it might be like, first, I can't do that, but I could change this into 12 root 7 because that's 2 times, that doesn't work. I can't do 2. Oops, that's not right. That's wrong. That's going to be, what is that going to be? That's 2 times 7. So I'm going to have to, yeah, so that one there, or you could do there when you're dividing those. Yeah, I'll let you guys work through those ones. I'll let you have a look and puzzle through these ones as we go through. So if you can have a go at these ones, oh, and don't forget, obviously, if you're dividing the denominators out the front, you know, that's going to be like 6 root 14. Oops, I'll do this, 14 on 12 root 7. So what you can do here is 6 and 12 obviously cancels out to 2. But I can change this to root 7. I'm running out of room. Let me just do this on a new page. That one's probably a tricky one for you guys. So it's going to be 6 root 14, don't forget, you can always change it into a fraction, which is easier to do, 12 root 7. So what will that turn into? You can cancel out your 6 and your 12. That will turn into a 2. So then it will change into root 14 onto 2 root 7. And if you think about that, that is root 7 times root 2 on 2 root 7. Root 7s can cancel out, which leaves you with root 2 on 2. And I should have worked down the page, not across. Yeah, I'll leave that with you guys there. And I'm just going to stop recording that. If you've got any questions,